Good afternoon, everyone. Today we're going to do a video on negative exponents. And so if you're in grade 9 here, you've probably seen exponents quite a bit so far. And so we're going to go a bit further today and look into the negative side of things. So let's start off by looking at a pattern of values. If I start you off with powers of 3, let's say 3 to the power of 4 you've seen is equal to 81. Next up, 3 to the power of 3 is 27. 3 squared is 9. 3 to the power of 1 is 3. And if you watched my last video, anything to the power of 0, namely 3 to the power of 0, is equal to 1. And so now, if we look at the pattern of what happens when we decrease our exponent by 1, we'll notice that the value of our exponent decreases by a factor of 3, right? We're getting 1 less multiple of 3 in here, and so our value decreases by a factor of 3. And that continues with every drop down by 1 in our exponent. And so now, since we're at an exponent of 0, if we go 1 exponent further down, we'll start looking into the negative exponents. So we have 3 to the negative 1. Now, it should follow that our value should continue with this pattern of decreasing by a factor of 3. And now if we have 1 divided by 3, we can simply write that in fractional form, which is what we continue to do, as 1/3, okay? And that's exactly what it is. Next up, let's look at 3 to the power of negative 2, and it should follow that it still decreases by a factor of 3, and so now we have 1/3 divided by 3. Okay, let's remind ourselves how to actually perform that calculation. So we have 3 to the power of negative 2 is 1/3 divided by 3. Now, I'll remind you that 3 is equivalent to 3 over 1, right? It's an integer, so we can write it over a denominator of 1. And now dividing by a fraction, which is, this could be considered a rational number, is analogous to multiplying by its reciprocal. Okay, whenever we flip a fraction over, the terminology for that is the reciprocal of that fraction. And so the reciprocal of 3 over 1 is clearly 1 over 3. And so now, 1 over 3 times 1 over 3 is 1 over 3 times itself twice. And so we can write that in exponent form as 1/3 squared, okay? Now, 2 things I want to discuss. What this really turns out to be equal to is 1 times 1, which is 1 squared, over 3 times 3, which means 3 squared. And now, whenever we're dealing with an integer base, we know that the denominator is always going to be 1, and so when we find the reciprocal, the numerator is always going to be 1. And we furthermore know that 1 to the power of anything is equal to 1. And so what we really have is 1 over 3 squared. And 1 over 3 squared, or if you'd rather write it as 1/3 squared, we're going to get a value of 1 over 9, whichever way we decide to go ahead and evaluate. Okay? So now we have the 3 to the power of negative 2 is 1 over 9. If we want to go one step further, 3 to the power of negative 3, well, it should follow that our value decreases again by a factor of 3. Okay? So we get 1/9 divided by 3. And we can write 1/9 as 1/3 times 1/3, just to highlight the concept. And so let's do that. 1/3 times 1/3 divided by 3. Dividing by 3 is the same as multiplying by its reciprocal. And so we'll have 1/3 times 1/3 times 1/3, okay? Which can be written as 1/3 times itself 3 times, and so 1/3 to the exponent of 3. Or we can write it as, that's 1 times 1 times 1 in the numerator, which is 1 over 3 times itself 3 times, and so 1 over 3 cubed. So 1 over 3 all cubed, or 1 over 3 cubed, because 1 to the power of anything is simply 1. And we know that if we actually evaluate this, we get a value of 1 over 27, okay? So I'm guessing you're starting to see a pattern with the negative exponents, and this isn't unique to a base of 3. This result is unique to integer bases, which means bases that are nice whole numbers, but this pattern would work with any base we may decide to use. 3, 4, 5, 5 halves, 4.5, 4.2, whichever, we'll see a very similar result. And so I'll write half a general result and then a really general result. So first, if we have an integer base, so if x belongs to the set of integers, then x to the power of negative a, which would mean 3 to the power of negative 3, that means some integer to the power of negative something, can be written as 1 over x to the power of positive a. Okay, so 3 to the power of negative 3 can be written as 1 over 3 to the power of positive 3. Likewise, 3 to the power of negative 2 can be written as 1 over 3 to the positive 2. Likewise, we can write x to the negative a can also be written as 1 over x to the power of positive a. Because I'll remind you that x is the same thing as x over 1, and the reciprocal of that, the reciprocal of x is 1 over x. And so if we have x to the power of negative a, we can write an equivalent exponent as its reciprocal, 1 over x, to the power of positive a, and drop the negative in the exponent. And so negative exponent simply flips the base. If we have x and we have a negative exponent, we can leave a positive exponent and flip the base to its reciprocal. Okay? And then more generally, if our base is a rational number means any number that can be expressed in the form of a fraction. Let's say we have x over y to the power of negative a. Then again, the reciprocal of x over y, let's write that explicitly, reciprocal of x over y is, we flip the fraction, we flip the rational number, is y over x. And so x over y to the power of negative a can be written as the reciprocal, so y over x, we simply flip the base, and now we drop the negative in the exponent to the power of positive a. Okay? So whenever you have a rational number to a negative exponent, you flip the base, and you drop the negative in the exponent. And if you simply have an integer value to the power of a negative exponent, you can write it as 1 over that same base to the power of the positive exponent. Okay? And so to give you one example of a fraction that would follow this rule, if I gave you one example, if I gave you 3/4 to the power of negative 2, then we can take the reciprocal of the base. The reciprocal of 3/4 is 4/3. So this would be written as 4/3. And now the negative 2 in the exponent becomes a positive 2. Okay? And now we can use our exponent laws. We know that 4 over 3 all squared, that can be written as 4 squared over 3 squared. And 4 squared over 3 squared, we know, is simply 16 over 9. And so 3/4 to the power of negative 2 is equivalent to 16 over 9. Okay? So, again, I hope this helps with integer bases and with rational bases. I hope this helps kind of see, starting with positive exponents that you're most likely familiar and comfortable with, down to exponents of 0, and then finally with the negative exponents. I hope you see that this is not a particularly complicated topic. If you're comfortable with positive exponents, you're going to be comfortable with negative exponents. It's simply 1 over, or it's simply the reciprocal base to the likewise positive exponent. So, I hope this helps. If you guys have any comments, suggestions, please let me know, and thanks for watching.